Hey guys, so today we're going to talk about limiting reagents. It's also called limiting reactants. You already watched one video, but just to recap about it, this is just like our recipes that we've been using as our analogy for chemical reactions. And sometimes we might have a lot, like say we have a whole bag of flour, but we only have a cup of sugar. So because of that, we need to account for the fact that we have more flour than we would actually be able to use in the recipe. So we will have excess flour left over, but if we only have a cup of sugar, we're probably going to use that whole cup of sugar. And so this can help us to figure out how many of our final product we're actually going to make, and then what's going to be left over, because it's sometimes we can't tell by looking at two things if we're just mixing two things together. It's hard to determine how much you're actually making and what all is going to be left over. So our definitions is the limiting reagent is the thing that runs out of first, and this is going to be a reactant, so it's going to be on the left side of our equation. And the excess reagent, or you might have more than one excess reagent, it's the stuff that's left over that's unreacted. So here's an example. It says you have 1 mole of N2 and 2.0 moles of H2. Identify the limiting reactant and the excess reagent. So in the past, I just gave you one of these numbers and you had to calculate it. Now we have numbers for both of these, quantities for both of these, and so we have to figure out and basically do the calculation twice, one with 1 mole of N2 and once with 2.0 moles of H2, and then compare those numbers to see which one is going to be limiting, to see how much we would actually be making of NH3. So in the video that I had you guys do the ed puzzle with before, it had you convert like into how much H2 you would need and then vice versa. You can do it that way. I'm going to show you a different way that I think makes more sense in my head, is that we're really comparing how much product can be made. So I'm going to convert both of these into our final product. So we're going to start with 1.0 moles of N2. And we're going to go ahead and draw our chart. And we're wanting to convert that into product to see how much product, if we use 1.0 moles and all of it reacts, how much would we actually be making. So we use our coefficients because we want to cancel the moles of N2 and we want to go to moles of NH3. So we see that there is no number in front of our N2, so that we assume is a 1, and then in front of NH3 there is a 2. So we're just converting to NH3. So our moles of N2 cancel, and we are left with 1.0 times 2, so 2.0 moles of NH3. And now we're not done because we still need to compare that to the 2.0 moles of H2. So now we're going to do another calculation. I'm going to just do it beneath it. So 2.0 moles of H2. And then we draw our chart. And then again, we're going to convert moles of H2 and we're going to go to moles of NH3. We look up at our equation because we have moles over moles. We're going to use our coefficients. And we see that there is a 3 in front of our H2, and there is a 2 in front of our NH3. So if you want, you can put it in the calculator. We have 2.0 times 2 divided by 3. We're going to get 1.33 repeated. We're only going to use 2 sig figs though, so we will write 1.3 moles of NH3. Okay, so now that we have these two numbers, we need to compare them. So this says if we use all of 1 mole of N2, we would make 2 moles of NH3. If we use all of 2 moles of H2, we would make 1.3 moles of NH3. So if we put together 1 mole of N2 and 2 moles of H2, we would not actually make 2.0 moles because we don't have enough, we only have enough H2 to make 1.3 moles. So because of that, the H2 that we make a smaller amount of, that is going to be our limiting reagent. So remember, it's whatever we're starting with. So it's not NH3, that's our product. It's always going to be the thing you started with. So our H2 is limiting reagent or limiting reactant, which means if we were to mix both of these and have the reaction go, we would make 1.3 moles of NH3, and then the rest of the N2 would just be there as N2, and it wouldn't turn into NH3 because there is more of it. So that means our N2 is our excess reagent or reactant. So I want you to notice that even though we started with 1 mole as compared to 2 moles of our H2, the one that had the smaller amount ended up being the thing in excess. So it's not necessarily whatever has the smallest amount that you're starting with, because we have to take into account our recipe or our equation. Because it could be that, yes, we're starting with less, but we don't actually need as much N2 in order to make our product. So we have to look to see how that relates to the equation. So we're going to try another one. So here we have 5.7 moles of N2 and 20.2 moles of H2. And again, we're identifying limiting and excess reagents. So 5.7 moles of N2. And again, I'm going to convert the reactants into products. And if you had more than one product at the end, it doesn't matter which one you would convert to, as long as you are converting both of your reactants into the same product so that you can compare them. So we would set up our chart. We'll put moles of N2 on the bottom. We will put moles of NH3 on the top. And then again, from our equation, we have 1 mole of N2 making 2 moles of NH3. That makes these cancel. We can put that in our calculator. 11.4, but we only have 2 sig figs. This is actually just going to be 11 moles of NH3. And now we need to compare that to our hydrogen amount that we have. So we're starting with 20.2 moles of hydrogen. And then we're wanting to convert moles of hydrogen into moles of NH3. And if you look in our equation, we have 3 moles of hydrogen for every 2 moles of NH3. And these cancel. 20.2 times 2 divided by 3. And we're using 3 sig figs in this case because 20.0 has 3 sig figs. And we'll write 13.5. Oops, 5 moles of NH3. So one thing I want to point out again is that notice that we only go to moles of NH3. You could, if you wanted to, take that another step further and turn it into grams and compare that number, but it's not necessary to do that, and it's just an extra step because we can compare as long as these are in the same unit. If you were given this number in grams instead of moles, you would then first have to convert your number to grams and then to moles so that you can convert to your product. So it's very similar to the calculations we've been doing in class already. Okay, so now we're looking, and the smaller number, the amount we would actually make would be 11 moles. So that means this is going to be our limiting. So our N2 is our limiting reagent. And that means the other thing that made more is H2 is our excess reagent. Because we would not actually make 13.5 moles, we would make 11, and then all the rest would be leftover H2. Okay, so you can try some examples on your own. So here's an example you can try. Okay, and so here's the answer to that. So if you convert both of these, you have 5 moles of zinc chloride, and then you'd have 8.5 moles of zinc chloride if you use the 17 moles of HCl. So that tells us that zinc is limiting and hydrochloric acid, or HCl, is excess. Okay, and you can try this one. Okay, so in this one, when you do these conversions, you get 23 moles and 3 moles of zinc chloride. And so that tells us that the smaller amount is what we're actually going to be making. That means HCl is limiting, and the other numbers for zinc, Zn is going to be excess. So I hope this is helpful in understanding the concept and how to do some simple calculations with limiting reactants.